This is part 2 of our tutorial on how to do time value of money calculations using the Hewlett-Packard 10B calculator. There's a couple more types of calculations we need to know how to do. For basic time value of money problems. The first is the present value of a mixed stream of cash flows. A mixed stream is a series of differing cash flows per year. So here's an example. Say you have an investment that provides cash flows of $100 for the first year, $200 for the next 2 years, and $400 in the fourth year. And we're going to be solving for the present value. So what is it worth to us today? What would it cost to buy that investment, for example? Our required rate of return is 10%. And again, we want to know the present value. So for present value of mixed string problems, we're not going to use the 5 time value of money buttons on the top row except for the interest rate button. We're going to use the CFJ button and then also the PRC button, which above it says NPV, or net present value. So we can use these buttons, the CFJ buttons, for net present value problems and internal rate of return problems. So we first need to enter our cash flows per year. So the first thing we need to do is let's make sure that our any numbers we've entered in previously are cleared out, because just as with the 5 time value of money buttons, the CFJ button stores any numbers you've put in previously. So let's go ahead and hit the green shift and the input button to clear out any numbers that we've already entered. Alright, so the first thing we need to do is put in 0 for CFJ. And it shows very quickly, it displayed 0, meaning the first cash flow. The reason we need to put in 0 at the beginning is because it says, all right, how much money is it costing you? What's your initial investment? Okay, you will do that. Use this for later types of calculations. But just for solving for the present value of a mixed stream of cash flows, we need to hit 0 in first. Now we can enter our 3 different cash flows. So we hit 100 CFJ, and you see the calculator will quickly display, it said CF1. You have to be quick or you'll miss it. But that's our first cash flow. Our second cash flow is 200, so we hit 200 CFJ. Right? Now the 200 happened in both year 2 and year 3. So we could put it in twice, but if you're having cash flows that are the same for, say, like 10 years, that would get tedious. So instead, what we can do is tell the calculator how many years in a row does that cash flow occur. You can see above the CFJ, there's an N sub J button, and that says how many number of periods does that cash flow happen in a row. So we can hit 2, shift, N sub J, and now the calculator knows that that $200 occurs consecutively in years 2 and 3. Our last cash flow is 400, so we hit 400 CFJ, and now we've got all our cash flows entered. Now again, our required rate of return is 10%, so we hit 10 and I/YR to put in the interest rate. And then we need to solve for the present value, or in this case it's called the net present value. So we hit shift and the PRC, because above it says NPV button, and you can see the present value of those cash flows is $679.67. Again, when we're done with that type of problem, hit shift and input to clear out the numbers we've entered. Alright, now what if you said, well, I need to calculate the future value of a mixed stream? Well, unfortunately, there's no quick way to do that. you would have to calculate the future value of each cash flow separately and then add them together. So like if we were doing the future value of that cash flow stream, $100 the first year, $200 in years 2 and 3, and $400 in year 4, you'd have to do them each separately to some time point in the future and then add them together. So I'll not go through an example of that calculation. Now another basic type of calculation you'll see is looking at compounding more frequently than annually. So maybe when the account compounds semi-annually, quarterly, monthly, or so on. Again, I would suggest instead of changing the periods per year in the calculator that you adjust the interest rate and the number of periods before entering them into the time value of money buttons. So here's an example. Say we have $100. We're going to put in an account for 2 years at 10% interest, and the account compounds semi-annually, or twice a year. So we're going to divide the interest rate by 2, and we're going to double the number of periods. So for 2 years would be 4 compounding periods if we compound semi-annually. So we're going to hit 4 for N, 5 for the interest rate, because note that the interest rate of 10% was quoted as an annual rate. Interest rates are always quoted as annual rates, but we want semi-annual compounding, so we divide by 2. $100 for present value and 0 for payment. Hitting the future value gives $121.55. Now, suppose you had an interest rate of 15.5% that compounds monthly. So you need to divide 15.5 by 12. All right, now you may be able to do that in your head, but I can't. So I need to use the calculator. So again, we could hit, first thing we could do is hit 15.5 divided by 12 equals, to get 1.2917, and then put that in our interest rate. All right. Now another type of compounding that you may see once in a while is continuous compounding, which is compounding every microsecond. So instead of using the time value of money buttons, we're going to have to use the exponential function. Okay? The e to the x button, which is above the number 1. Okay? This is the base of the natural logarithm, and so we use that for continuous compounding. So we have to work at this type of problem slightly differently than a regular compounding problem. So let's say we have $100 in an account for 2 years, continuously compounded at 7%. We first have to take the interest rate as a decimal, or 0.07, and multiply it by the number of years we leave it in the account. So times 2 gives 0.14. Then we're going to hit our shift button and then hit the number 1, which is e to the x, to get our future value interest factor of 1.1503. Alright, so this is the factor that you multiply by the deposit of $100, so times 100 equals, to get the future value of $115.03, rounded up. So again, using continuously compounding, you have to take the interest rate in decimal times the number of periods, and then put that into our exponential function to get our future value factor, and then multiply that times the present value. Now suppose you wanted an effective rate using continuous compounding. If you're given a nominal rate, for example. So if we had our nominal rate of 7%, to get an effective rate, again we put in the interest rate as a decimal, 0.07, and then hit shift e to the x to get 1.0725, and then we subtract 1 to get our effective rate of 7.25%. Now that concludes the basic type of calculations you'll need to be able to do in using time value of money. This concludes part 2 of our tutorial.